Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 18th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see a low-pressure system north of Hawaii generating a little bit of fetch and, maybe 12, 14-foot seas, generating some wind swell that's hitting the north shore of exposed islands. But other than that, pretty calm pattern is in play for the moment over the North Pacific. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough that is a dip in the jet to the south, just like that right there. What that helps to do is create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And if the low pressure is deep enough, it generates winds. If the winds are strong enough, they generate seas. If the seas are high enough, they radiate away from the fetch area and eventually turn into swell. And swell, if its period is long enough, eventually generates surf when it hits your beach. Right, so we have a trough, not a real classic kind of trough. It's cut off. The main flow here pushing off Japan, winds moving 120, 130 knots, then falling south, but a lot of energy passing north of the trough and then pushing into central Canada. Still a little bit of energy falling south, just enough to generate low pressure, not even a gale, just something to generate some winds, and that is having the desired effect along the Hawaiian Islands. They are getting rideable waves, a couple feet overhead. That's certainly better than nothing. All right, moving along into Monday, the trough starts fading a little bit, less winds moving into it. And then as you get into Tuesday, notice winds in the jet build to about 170 knots and start falling back into the trough, but the trough is very pinched. It'll have a hard time getting, a broad circulation going. Maybe just enough for low pressure, and that's about it. But then also notice as we get into Wednesday night, something that almost looks like a standard kind of trough is developing. Also notice off Japan we have a ridge, that is the jet pushing to the north, and that generates high pressure aloft. And the same deal off of California. This is blocking ridge, just locking high pressure down here. But notice the jet dipping south, producing some weather pushing into, we say Washington, maybe North Oregon as we get into Wednesday night. But this is going to be our focus right here. The trough with 150 knot winds down in its apex, down on the bottom of it, good enough to generate maybe a little bit of fetch and a little bit of something of interest. Then Wednesday, another batch of wind energy pushes into that trough, but again, getting pretty pinched off pretty quickly. But this seems to be the pattern as of late. Just this like standing wave trough just northwest of Hawaii, pinched with high pressure off Japan and bulletproof high pressure off the U.S. West Coast. Anyway, the trough continues as we get into Sunday morning, but still very pinched, but persisting. At least that offers some hope, and that's 180 hours out. Also notice the jet pushing south inland. That's kind of a classic La Nina sort of thing. All the storm energy goes up here. You get cold, relatively drier air pushing south down the Cascades and into the Sierra, but it does generate snow. And when it does that, it's pretty cold and it's pretty light quality snow, light, good ski quality and snowboard quality snow. So if it were a little bit later in the season, we'd be eyeing that closer. But for now, there's nary a flake to be found. So let's go take a look down at the ocean surface and see the effect of the jet stream on surface level pressure. No big surprise here. High pressure 1020 millibar right there over the date line. Another high pressure system 1028 millibars off the U.S. West Coast. And then the trough digs right here, and we have just the weakest, I'll click away here, just the weakest of low pressure systems. What was that, like an 1008 millibar low right there? That's and 25 knot wind, so wind swell at best. And as we get into Monday, even that dissipates, fades. The low builds, but it's starting to lift north, of no real interest. Then we start watching this area over the date line. Low pressure builds, 35, 40, almost 45 knot winds on Wednesday night. and then backed up by more 30 and 35 knot winds as we get into Thursday, building over a pretty good area. So the models have been like going back and forth on what this is going to do. This is one of the more favorable runs, the 18Z run of the model. The 12Z run wasn't as favorable, but regardless, not a big system, but at least something that theoretically could generate some swell, 30, 35 knot winds as we get into Friday and then fading out. Big high pressure driving, low pressure over, moving towards Kamchatka, not getting exposure in the open ocean. High pressure and control of the Northeast Pacific. And where are we? We're in Sunday, and it looks like we're going to end up exactly where we started with high pressure and just non-discriminate low pressure. So at least there is hope for one system over the dateline about midweek. Let's go see the effect of those winds on the ocean surface. Here we go. So today's view, and let's see, let's see that. That is 8, 9, 10, 11, 12, 13 feet. Oh, 14.3 feet, sorry. Okay. 14-foot seas northwest of Hawaii. That's what's generating wind swell. That's good for maybe some 11-second period wind swell. It's not even aimed directly at the islands. It's aimed more south. I guess that'd be west of the islands. But still, that's generated some wind swell, and that's supposed to continue, but slowly fade as we get into the week. But then we start looking for the Wednesday time frame when this gale develops over the North Dateline region. 26-foot seas as we get into late Wednesday, early Thursday, pushing off to the east, and a broader area of we'll call it 23-foot seas, continuing to Thursday night, Friday. That aimed well at California. That'd be a pretty north angle, just eyeballing it for North California. That's probably about 305, 306 degrees. And sideband energy pushing down to Hawaii from probably 335 degrees, something like that. And then that fades out as we get into Saturday, and after that, everything kind of goes to sleep. And there we are at 180 hours out. So there is no swell other than the wind swell hitting Hawaii in the water right now. But there is some indication that maybe we'll have a swell being developed midweek, radiating towards Hawaii and the U.S. West Coast for next weekend. Now looking down south, there was a gale that developed on Monday night almost a week ago, with 34-foot seas, building to 40 feet, building to, 43.5 feet. Southern California, the cutoff is about 118 west right there. And notice most of the energy aimed off to the east, and I'll say the east-northeast, but still some sideband energy is expected to radiate up into California midweek or so, maybe Wednesday. And that continued out of the California window by Wednesday last week and was gone. We'll just sort of step through this to see if anything else happened. We're looking for 30-foot seas pushing off to at least to the east or the northeast, and there is nothing on the chart for that. So then looking forward, the models were pretty pessimistic up until about this model run. And then all of a sudden, you see little batch of 30-foot seas forecast on Wednesday, maybe 30, we'll call it 33 feet, aimed off to the east. We'll see if that really holds. Then a broader system is now forecast pushing under New Zealand on Saturday. That's almost a week out. Probably not believable, but it looks like a good tease for now. It's still reasonably possible given the time of year and given just the way of the year. It seems like winter is definitely delayed. We're still in like a early fall pattern. And so, it's possible we could see this system, which would mean swell for Hawaii and the U.S. West Coast if it materializes. But we're just going back and look at it. So that's a pretty good duration. We'll pick it up there all day Saturday into all day Sunday, 32-foot seas over broad area. So theoretically, swell could result from that. We'll see. Of more interest, though, take the swell you can get, which is coming midweek. And if this happens, that'd be great, but don't count on it. And then, of course, the wind swell forecast. High pressure in control of the Gulf of Alaska. We're watching the Cape Mendocino pressure gradient, Cape Mendocino Point Arena. 20-25 knot winds. Waves in Northern California today were very small, thigh high, something like that. almost says north winds, but they were almost northeast. No surprise that very little was pushing into the coast. So we get into Monday. We're also looking at Hawaii here. Trades, but very light. Not a whole lot in terms of wind swell generation potential. There's that low, though. The other side of the low that you can't see, that's generating the wind swell that's been hitting Hawaii. Anyway, Monday, wind swell building. North winds 20-25 knots over a broader area, pushing 30 knots late on Monday. As we get into Tuesday, 30-knot winds, building wind swell, but light winds along the central and even North California coast up to almost south of Bodega Bay. That continues into Wednesday. In fact, the fetch area builds with 35-knot winds, and then it really starts nuking off at Cape Mendocino and Point Arena. For that matter, the whole Northern California coast as we get into Wednesday night. Let's see, little tiny area 40-knot winds continuing into Wednesday night. And there we go, Thursday morning, broad area 40-knot local winds. That's like gale status. So big wind swell possible, but notice right up along the coast. And this is not some super high res model, but you get the sense that there could be light winds at spots along Central California and even up into the San Francisco Bay Area. So if you know where to go and know how to play this search game, you might be able to get some decent wind swell. 40-knot winds continuing into Thursday night. And then finally, that gradient collapses as we get into Friday. Wind swell fading out, but not completely because there's still north winds in control. So we get into Saturday. I'm looking at Hawaii. Nothing really significant going on there. And yet, as we get into Saturday night, again, 30-knot north winds. This is like summertime, only it's almost Halloween, and we got the full pressure gradient going on. This gives you some hint of what we're in for this winter. High pressure, quite strongly in control. That's typically what happens during La Nina, and so none of this is a real surprise. And again, if there's waves, go surfing. Don't wait for the perfect swell. And then precipitation forecast for California. High pressure you see in control. Bulletproof for the most part. But if you notice here, we'll get into this as we get into right about here. A low pressure is forecast, low pressure system forecast developing. Remember, the jet's going to be starting to push down south over the Cascades and Sierra. So we get into Friday night. No surprise, little low pressure system. Snow for the Cascades, early season snow. So we get into Saturday. Rain down into Cape Mendocino. And then maybe even a dusting of snow, theoretically, Saturday night into Tahoe and even Mammoth, if you believe the models. This run is the only one that's shown that. This morning's run, nothing there. But yesterday there was a model that suggested a couple of inches for Squaw Valley, something like that. But that's probably pretty low odds of happening, but certainly cooler temperatures possible, especially up high. All right, let's go take a look long-term. What's going on with the MJO and, of course, La Nina. First off, we're going to examine the MJO, the Madden-Julian Oscillation. This periodic weather oscillation, it rotates around the planet. Active phase in one half of the planet, inactive phase in the other. The active phase, both phases, travel west-east along the equator. When the active phase is pushing across the Pacific, it takes about 3 or 4 months to do. 3 or 4 weeks to do that. When it does that, it's basically a low-pressure system. It has a tendency to reverse the trade winds and create precipitation, cloudiness, and that feeds energy to the jet stream, and that feeds the storm track, and that makes surf. When in the inactive phase, it does the exact opposite. Sets up high pressure, pushes the jet stream north, and doesn't do anything to support storm development. All right, so evidence of the active phase of the MJO would be a reversal or a slackening of trades in the West Pacific, what we call the Kelvin wave generation area. The area far West Pacific, that's right here. The equator's right here. This is the East Pacific from 135 east to the date line's right there at 180, just east of there, like 170 west. 5 degrees north and south of the equator. When you get suppressed trade winds in this area, that can help take warm water that's typically here, push it off to the east. If that happens, if you get multiple active phases of the MJO and multiple suppressed trade wind, what they call westerly anomaly events, that can help kick off El Nino, but we're nowhere near that at this point in time. Looking at the arrows, this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. Look at the arrow length, suggests strong easterly trades in the East Pacific, the Central Pacific, and over the Kelvin wave generation area. No hint, supposedly, of the active phase of the MJO. But it's actually the anomalies, differences from normal for this time of year. You see here in the East Pacific, no arrows really at all, neutral trades, so they normally are pretty strong here. Over the Central Pacific, though, you see easterly arrows starting to build, easterly trades. Then you get into the Kelvin wave generation area here, and you see, in fact, pretty solid, we'll call it moderate easterly trades in control. So just looking at this chart, one would say we are in the inactive phase of the MJO. Let's go take a look at the forecast for the next 7 days. All right, so this is the same style chart, but a little bit different. The blues are easterly anomalies. The reds and yellows are westerly anomalies. We want to see westerly anomalies in the Pacific Ocean. But this is the whole planet on one chart. The date line runs right up the middle. That doesn't give us any good signs at all. Kelvin wave generation area, that's where we really want to see the westerly anomalies, because that's not only where we get Kelvin waves from, but also that's the main area for feeding the jet stream over the entire Pacific Ocean. So 135 east, that's the east end of the Kelvin wave generation area. I'm sorry, the west end. The east end is at 170 west right here, so you just go right up in the center of the chart here, and we see, this is time here, all September we've had easterly anomalies, strong easterly anomalies as we got into October, and the forecast is strong easterly anomalies continuing for about another 3 or 4 days. And then thankfully, it looks like easterly anomalies are to continue, but start weakening. So maybe that would give us a little window there to help support storm formation. Looking further out, these are MJO forecast charts. Outgoing long wave radiation. So the MJO is not all just about winds, but also about cloud cover. And OLR, outgoing long wave radiation, is fancy words for cloud cover. Blues mean a lot more cloud cover, which means the active phase of the MJO. So what are we looking at here? Here's South America, Central America there, Mexico, equator, EQ, runs right across the middle there. New Guinea there, date line right there, Kelvin wave generation area. That's what matters right here. This suggests, the statistic model suggests the active phase of the MJO is in control of the Kelvin wave generation area. And it's supposed to continue 5 days from now, maybe a little weaker 10 days from now, and still holding on, but a little bit weaker 15 days from now, 2 weeks from now. Interesting. The active phase of the MJO is in control, but we saw in the previous chart, easterly anomalies are blowing and forecast to hold, maybe weaken about 4 days from now. So that's this. If this is the active phase of the MJO, and normally you're supposed to get westerly anomalies in the active phase, what is going on? You probably already know the answer, but we're not going to tell you quite yet. We're going to dig a little deeper here. Then the dynamic model. Okay, basically painting the same picture. Active phase of the MJO. The two models are in agreement. They say the active phase is happening, yet we still have easterly anomalies. And then it's supposed to fade about 2 weeks out. Okay, well, strange. Active phase happening, but the winds that it's supposed to make are not happening. That's not good. That's not feeding the jet stream the way we'd like it. Phase diagram charts, another way to examine the exact position of the active phase of the MJO and how strong it is. How you read this chart, see that circle there? Assume you're looking down on the North Pole from up above our planet, okay? And the MJO runs from west to east out around the equator, from the Indian Ocean to the Maritime Continent, to the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Wherever the active phase is, the inactive phase is on the opposite side of the planet. The heavy dot is where the active phase is. The further the dot is away from this circle, the stronger it is. So we'll call, let's say, modest to moderate active phase of the MJO, pushing off the Maritime Continent, pushing towards the West Pacific. And the forecast is for it to stay a little bit strong for maybe a week and then start collapsing as it gets into the West Pacific. This per the statistic model. The dynamic model saying pretty much the exact same thing. Over the next 2 weeks, active phase moving to the West Pacific, getting progressively weaker and sort of fading out. That's what the previous two charts showed. And these are actually the same two models, just a different rendering, the phase diagram rendering of what those models were depicting graphically. All right, next up, upper level model, okay? This shows you propensity for precipitation. The active phase of the MJO, since it's like a low pressure system, creates precipitation. So wherever the greens are, precipitation. Areas favorable for precipitation are over the, okay, how do we read this? South America there, Central America. Equator is at 0 right down there. Dateline roughly there. New Guinea, Australia, you get it. The greens over there. Active phase of the MJO. Okay, active phase of the MJO over the Kelvin wave generation area. Forecast to make its way across the Pacific into, we'll say about November 7th or 12th, something like that. And that is our sweet spot for swell development. And then the inactive phase comes in on November 2nd. Makes its way across the Pacific through the end of the model run, about Thanksgiving. But as we get into Thanksgiving, you see the active phase starting to redevelop in the West Pacific. So this model also confirms what we saw in the other models. We're in the active phase of the MJO right now, but we still have easterly anomalies. And then one more model, the CFS model. Now this one goes out a month, okay, which gives you a hint of what's to come. Again, whole planet on one chart. Kelvin wave generation area starts 135 east right here. Goes to about 170 west right there. You can see, and the forecast starts right here, the 17th of October. Blues, easterly anomalies, in control, and only forecast to build as we get into November. Now, what do we have here? This solid contour. This is the active phase of the MJO. You see it. It's been pushing from the west to the east, trying to push over the Kelvin wave generation area. It literally gets stomped on as it hits the Kelvin wave generation area, and then redevelops as it pushes 120 west, that's south of California. So redevelops on the other side of the Kelvin wave generation area, and then continues its merry trip around the planet. What is going on here? Well, this dotted contour is what we're calling the high pressure bias. It's basically La Nina, okay? So the active phase is forecast to try to push over the prime swell development area, what we call the Kelvin wave generation area. La Nina is in play here, and it is the dominant weather system. It stomps on the MJO, just takes all its westerly anomalies that it's producing over here in the Indian Ocean and over here in the Eastern Pacific, and just they just vanish, and easterly anomalies reign supreme. Then also you see the inactive phase of the MJO developing over the Indian Ocean mid-November, and that at some point will move across the Kelvin wave generation area. And when it does that, so think of La Nina as a massive inactive phase of the MJO. When it lines up with the inactive phase of the MJO, the two of them get together, they're in phase, they produce strong easterly anomalies. But when the active phase of the MJO tries to pass over La Nina, they're out of phase. It basically just sucks the wind out of the active phase of the MJO. It doesn't do anything, just renders it impotent and useless until it gets away from the high pressure bias. Then the active phase wakes up again. So that sort of looks like where we're at. Then we go out even longer term. This is the 3-month CFS model. Same deal. Kelvin wave generation area starts here, runs the whole way up, and goes to about here, 170 west. Okay, but this is past performance here. This is future performance. Just looking at the past performance in this area, all I see is blues, easterly anomalies, other than one little active phase of the MJO. I'm just guessing looking at this right in here because there were some westerly anomalies around mid-August. Okay, the forecast playing the same game. Easterly anomalies pretty strong in control till we get into maybe the December time frame. But this model it's been constantly like trolling of some long, strong active phase of the MJO coming 2.5 months out, and it just never materializes. All right, that's just eyeballing this. Let's overlay the MJO, see how close we are. All right, so here's our active phase of the MJO that's going on right now, but you notice no real westerly anomalies. And when you take this away, you go there, could you really discern that this is the active phase of the MJO? I can't. There's a couple of little patches of westerly anomalies, but even that is probably a optimistic guess at best. All right, so that goes into we'll say Halloween or so, a little bit beyond. Then here comes the inactive phase of the MJO. It gets in sync with the La Nina base state. Pretty strong easterly anomalies over here in portions of the Pacific. And then here comes the troll, the supposed active phase of the MJO developing in December, continuing on into about Christmas time with strong westerly anomalies. We'll believe that when it happens. And then beyond that, inactive phase with remnant westerly anomalies. So the real question is, how long is this La Nina base state going to last? Well, anyway, here, let's overlay the low pass filter. This really tells the story. The dotted contour, high pressure bias, sitting right over the smack in the middle of the Kelvin wave generation area. That's what's negating any westerly anomalies that come with any active phases of the MJO that take over the area. You see two contour lines in control. Model suggests it's maybe supposed to nudge off to the east a little bit, but still pretty much controlling the Kelvin wave generation area even as we get into mid-January. Low pressure bias, this solid contour, over the Indian Ocean, building, strong. We're almost beginning to get the sense that maybe we were hoping this was the second year in a 2-year La Nina pattern, but we're beginning to think that maybe that might be a little bit optimistic just based on the strength of all this. I mean, it's typical for La Nina to peak in the January timeframe, and we assume that's what's going to happen. The real issue is how quickly can you recover from the damage wrought by La Nina, and will that allow us to have a normal fall a year from now? And that is very much in doubt at this point in time. All right, so enough about the MJO. Let's go dig into the La Nina scenario. First component we want to look at, subsurface ocean temperatures. So we're going to talk down in the ocean surface, then we're going to talk at the surface, then we're going to talk the air above the ocean. The ocean drives everything, and temperatures in the ocean are very impactful on what happens in the air and the circulation above the ocean. All right, so West Pacific here, East Pacific here. Data from the TAO buoy array. Again, those buoys strung across the equator used for monitoring El Nino. Here are the anchor lines on those buoys. The X's are sensors that are on the anchor lines. The data collected from those temperature sensors, radioed up, bounced off satellites, sent to a central processing facility, run it through a model, and with that you can get a view of the water temperature profile the whole way across the Pacific at depth. And clearly you see these temperatures are in centigrade. You can't really see it, but that's the 29 degree centigrade isotherm. Warm water here in the West Pacific, holding about where it's been all along. The 28 degree isotherm pushed way off to the west at about 178 east. And the 24 degree isotherm, it was at 135. It's almost backtracking a little, maybe 137 west. What's this mean? Trades we know are nuking, have been. They're taking warm water in the West Pacific, pushing it all to the, in the East Pacific, pushing it all to the West Pacific. And what you end up is this deep, they call it a thermocline angle. So when all the warm water is balled up in the West and you have cold water in the East, you get this kind of downward sloping pattern. And that is typical of La Nina. And anomalies, difference in temperature from normal. This really tells the story. Here's your warm water in the west, and it's even not that warm. 1 degree above normal in one little pocket here. The date line is, I don't know, we'll look right about there. So right there, okay. Barely making it east of the date line. Cold water, 1, 2, 3, 4, almost 5 degrees below normal. That's like, just off the top of my head, 9 degrees Fahrenheit below normal. This is 5 degrees centigrade. That is quite cold indeed. No surprise. La Nina in control. East trades nuking. High pressure at the surface, just driving a strong easterly flow. And this is a classic La Nina pattern. One other model here. Same raw data. Basically telling us the same thing. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We'll call it 4.5, 5 degrees below normal. So confirming what we saw in the other image. You see a little bit of warm water there, but and that could be completely an anomaly. What you really see is a massive pool of colder than normal water controlling the entire equatorial Pacific, at least to the date line and even east of there. High pressure because it does not support cold water because it does not support evaporation. It shuts down evaporation. That supports high pressure. And then you get, like what we've been seeing. A lot of north winds along the coast in California, dry, no precipitation, storm track, definitely not in the Pacific. Elsewhere on the planet, this is kind of the symptoms of it. Upper ocean sea surface temperatures, same sort of chart, but this puts the time factor into it. See November of last year, October of last year, going back in time. This is the West Pacific here, the East Pacific here. The reds are warmer than normal temperatures, the blues colder than normal. You can see last fall, you can see literally Kelvin wave. One there, another there, pushing across the Pacific. And then we got to May 2020. Someone flipped a switch. The Kelvin wave machine shut down. Trades woke up, started nuking, upwelling, cold water developing off of Ecuador, making it the whole way to the dateline. Sort of took a break there in July for a month. And then, boom, here we are again. More cold water. This is, again, the typical La Nina signature. And you can see it here. This is just the total upper ocean heat anomaly pattern from the dateline the whole way to almost to Ecuador. Warmer than normal, November 2019. You can see it. We got to April, and there was the switch flip. One big cold pulse, a bit of a break in July. And notice, we had a big, pretty good southern hemi swell right there when that happened. I bet you the active phase of the MJO was hitting then too. Then boom, right back into the lockdown and cold water in control up to today. The high-res zoomed-in sea surface temperature. So we're not looking down in the ocean anymore. Let's go look at the surface. I mean, nothing really to tell here. This is exactly what we saw last week. So there is Mexico, Central America. What's that? Ecuador. I think Colombia's right there. Ecuador, Peru, Chile. The blues, colder than normal temperatures. The equator right there. And you can just see cold water, very cold water in pockets. This whole big like triangle thing from down in Chile to Ecuador, but not arching up into Mexico so much, at least according to this. In fact, temperatures pretty much above normal elsewhere other than right at the equator, which is a little bit different twist on things. Sometimes you see the cold water working its way up here, but not so much, at least yet. Sea surface temperature trend for the past 7 days. Warming, slightly warming here in this area. Well, and that's not surprising. The active phase of the MJO is trying to make its way across the Pacific, so trades that have been nuking are actually getting tamped down a little bit, so temperatures are warming. This doesn't mean they are warm. They're just not as cold as they were a week ago, but you still see cooling setting up south of California. There's Hawaii. There's the dateline. The whole way to the dateline, from south of California to the dateline, still temperatures getting cooler, but a little bit of warming in the far East Pacific. And then the overview. Obvious, massive, cool temperature tongue filling the entire equatorial Pacific. We expect this to build up this way at some point, but for right now it's not doing it. Mainly confined to the southern hemisphere, but it's really just 5 degrees north and south of the equator. That's what really matters, and it is well entrenched. It has been this way for weeks, months, and no change is expected. Nino 1.2 temperature values. This is the area right up there along the Galapagos, Ecuador, just off Peru. Temperatures have been cold. Rock solid steady today, minus 1.649 degrees right there. We did have a dip down even in the sub 2 degree range in in August. But generally, we'll call it about 1.6, 1.7 degrees. No change there, but this is not the official El Nino monitoring region. This is sort of the noisy region. It can fluctuate pretty wildly here. But the official Nino 3.4 region, the area on the equator from south of California out to about the dateline today, You see the trend steadily downward, minus 1.163 degrees. You go, hey, it's only a degree. That's not that much. Well, the reality is a half a degree for 5 consecutive 3 months periods is the difference between El Nino and La Nina. If it's warm half a degree for that length of time, then theoretically it could be El Nino, and a half a degree on the cool side is La Nina. We're well past that. We're double that and then some. So clearly looking like a La Nina pattern set up here. And this is real data. This isn't model data. This is actual, I believe it's satellite measured data. You can't really argue with it too much. Then finally, looking at the atmosphere above the ocean, we're talking the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti, of course, is in the Pacific Ocean. When the index is negative, that suggests the lower pressure in the Pacific, positive, higher pressure in the Pacific. Today's value, minus 7.74, suggestive of the active phase of the MJO. And you can see we've been negative for a couple days in a row now. But the 30-day average, that's really what matters. That takes all the noise out of this because the daily contribution, it can be pretty noisy, but it has been generally quite positive for quite a while now. Whoops, there we go. All right, the 30-day average, positive 9.66. We were up at 12.58. But with the active phase of the MJO taking over, it's knocked the SOI down a little bit. The 90-day average, 8.44. We were up to 8.84. I think that was our peak. But it's still, the general idea is it's going to continue to go upward. Once it hits about 12, you're fully in La Nina territory. But this is a lagging indicator. You see the 30-day average, we were already at 12. And have been hovering in the 9 to 10 range for a month now. So the thought is we clearly are in La Nina territory. And then finally, the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. We have been positive. You see back January. Then in April, the temperature trend turned towards negative. We got to July. We've been on a steep decline. And then what we have learned here, one of our readers, one of our viewers dropped us a note and said, actually, this January or any of these tick marks here, that is not the first of the month. That is the middle of the month. All right. So this shows, so right now we're mid-October. This is right where we are. This is confirmed. And, you know, this all makes sense now. It says we're at -1, and that's where we were on the satellite base temperatures. So we're right on track. This going down to supposedly minus 2.45 degrees in mid-January. That's indeed quite cold. That would be significant or indicative of a significant La Nina. Then theoretically, a quick rebuild from there as we get into mid-July back to normal. But even if that happens, just because the water temperatures get to normal doesn't mean that the atmosphere above it's going to return to normal. My guess is it would take 3 to 5 months, so we wouldn't get back to a normal state probably till Thanksgiving, Christmas of next year, something like that. So when we say a 2-year La Nina, I mean, the second year wouldn't be a full La Nina. It'd be more of a recovery year, but atmospherically, if you're only returning to normal at around Christmas time of next year, that pretty much wipes out the rest of that year too. So we'll see. We'll see if we get down to this low point, though most data seems to indicate we're moving towards a pretty strong La Nina for right now. So more to follow on that. So the good news is there's southern hemiswell on the way for California. Maybe not for Hawaii, but California. And there's maybe a forecast of another tiny 1, maybe 2 pulses to follow behind that. And there is in the North Pacific a gale forecast for sure on the dateline in a couple days from now. That seems reasonably good odds of that happening. So there will be surf, and then of course plenty of wind swell for North and Central California for the foreseeable future with relatively light winds near shore. So take what you can get, make the most of it. The suspicion is the deeper we get into winter, there will still be storms. La Nina does not mean there won't be storms, that there won't be surf. We've talked about this before. But that those events, when they do happen, will be short-lived. The surf won't be as big, won't last as long, that sort of thing. So you need to take what you can get and make the most of it and be happy for it. I mean, we've had a pretty good run of surf the past couple of years, so it's time to pay the price. The sooner we get it over with, rip the Band-Aid off, all those cliches, get it done with, and then we can move on to a better regime looking forward. All right, if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe. You get a notification when we post the video. If not, go to stormsurf.com. All the data you're seeing here is available there. And the links to the videos are also available there. So if you don't want to subscribe, that's fine. Up at the top of the page, any of the pages in Stormsurf, you'll see a link to the video after we post it, and you can watch it that way. All right, thanks for watching tonight, and we're going to do this again next week. Same time, same channel. Thanks for watching.